You have to always remember this back minus cab rule, and this could be, it could involve multiple back minus cab rule applications. It shouldn't get lost. Okay. Important here again is B cross B cross C not equal to okay. So A cross B cross C is not equal to A cross. If you change the bracket, it changes the whatever you want to change. Want to do an example? Alright, for a second apply your mind now, okay? Just try to visualize what I'm trying to ask you. Don't take any notes. Just hang on and try to think about this. This is how you visualize vectors. This is how you realize vectors, okay? I'll give you an example. You are given two vectors. The question you are asked is, okay? So you are given two vectors A and B, and you are asked find the unit vector which is, you understand this sign, perpendicular, which is perpendicular to A and that which lies in the plane of A and B. Huh? If you use cross product, what are you going to get? So first of all, these two are not perpendicular. These two are not orthogonal. It's not given to you that these two are orthogonal, right? So just imagine this. Okay, this is vector A, vector B. If you take the cross product, what is going to happen? This vector, whatever you get, is going to be perpendicular to A and B. But will this condition be satisfied? It will not be in that plane, right? Because we know when we take the cross product, the vector of the cross product is perpendicular to the plane. So it is not in the plane. So what do we do? Projection of what? Don't guess. Think about it. What is the question being asked? Can you understand what the question being asked is?
It's asking for a vector that lies in the same plane as vectors A and B. So I'm thinking, don't be in the I'm not sure which direction we're at, but the vector that will be produced with cross product, I think that needs to have a direction of 0.
Don't think about ijk. These two are vectors, three vectors. Huh? Think about how you're going to go about it. And this is critical to this whole course. This is how you visualize course. This is how you visualize vector mathematics.
What is the direction of the unit vector go?
It is given to you. Unit vector is perpendicular to A, and it is in the plane of A and B.
Times unit vector B.
Find unit vector perpendicular to
All right. Can everybody see this? Huh? These two are your vectors. Okay. These two could be your vectors. What is the plane formed by these two vectors? Huh? The table is a plane formed, right? So any two vectors will form a plane. If you take these two, what is the plane form? This, whatever it sweeps, right? And if you take a cross product of these, you're going to get this, right? This is perpendicular to A and B. If you take the cross product of these two, what happens? It will go back to this plane, right?
Yeah.
But now it will be perpendicular to A and that original vector. And if you just normalize it, or you make it unit vector, that is your vector.
No.
Did you get it?
No.
So you have vector A, okay, vector B. If you take the cross product of these two vectors, you're going to get this, right? These, do you see this as perpendicular to these two vectors? Right? This is vector A. This is that vector which is perpendicular to vector A and B. I take the cross product of these two.
Yeah, well, what was confusing me was Carlos said it lies in the plane of A and B.
Right, if I take the cross product of these two,
Oh, then it'll be in the plane.
it has to be in this plane, and it has to be perpendicular to both. To A. B we are not concerned. Right? It will be perpendicular to this, but we are not concerned with that. We just want perpendicular to A and lying in the plane of AB.
So we would have written this out like in parentheses A cross B.
It's not about writing, but try to understand visually what vectors mean. Orbital mechanics is about visualizing vectors, how vectors rotate. So when you take cross product, what happens? Right. So if you're asked a question like this, you have to visualize. You have to first think about how you get there. Does it make sense? Does this make sense? Everyone? So now you do the math operation. So now, how do you write down the math operation? So first you do let's say a temporary vector C, which is equal to, let's say, A cross D, okay? So this would be I, J, K, minus 3, 7, 9, 6, 5, 8. Going to get equal to 56, 45 is 101. Minus J, 24, 54, 78, right, yeah. Okay, 42, got it? Now if you take A cross, so do you want to take A cross C or C cross A? See, it's important that you take the right vector, right cross product. It will not be the same. If you have this, right? We have arrived at this. This is C vector, right? A cross C would be this. C cross A would be this. Right hand rule. A cross C would be, so you A cross C, right? A cross C. C cross A would be, but incidentally both of them are perpendicular to A and B. A vector. So you don't really. So now if you take what is U A C, is A cross C over A cross C is this vector. Okay? If I had just had this is the unit vector, this is a vector perpendicular to A cross C, right? If I want to normalize it, or if I want to make it unit vector, what I'm going to do is, I'm just going to divide that by the magnitude of A cross C. Okay? So you can complete this part. Can you complete this part? So another example. Alright, I want everyone to do this in class now. Huh?
We can do a separate sheet of paper or in our notes?
Your notes. So F. There is enough time to do this, so try this. This will be your first quiz. This is your first quiz.
So you don't want it in my notes?
You can have it in your notes.
It's gonna try to send it.
Huh?
We just gotta start on that.
Maybe you can walk around and check it out.
Trying to figure out if we're handling this issue. Because if not, if we are, we want to write on a separate sheet of paper.
Okay, write it on a separate sheet. So express F as an expression involving dot product using the back minus cap rule. Huh? Yeah, F. This? Yeah, E. F is equal to E cross B cross A cross B cross C.
And what it has in
Quiz, it's a quiz. In class quiz. Express F as an expression involving F is equal to E. Sorry. This is how I would start. I would say something like this. B cross C. Let it be some vector then my expression becomes F is equal to now I'll say G A cross G. Let this be equal to H. F is equal to right. This is what you can solve. And then you solve you split open H, you split open G. and then solve it inside. Apply back minus cab rule to this. You can see it?
Yeah.
Back minus cab rule. No? You have to expand G and D.
Oh, you want us to like,
Yeah? You have to split over G and D now.
want it as simple as,
There should be no cross symbol.
what about that?
It's all dots.
Do that now.
G and D. You have to split over G and D.
Edit.
No, you're not.
You want me to like leave that?
Yes.
Oh.
Then that is. Right now, split open G and D, or H and D.
What do you mean by split open?
H. You have to substitute back H.
Yeah, substitute everything.
Everything back. It cannot be in terms of H. It has to be in terms of A, B, C, D, E. Everything has to be in terms of A, B, C, D, E. If that is the case, then you have done nothing. You have just showed me the back and cab rule for a new set of letters. What is G?
What's the first expression of cost each cost? But no, I didn't do that. I started before you started writing that, so I didn't know.
Is this what you want to submit?
Huh?
Is this what you want to submit?
I mean, if you want, if there's an error, you can give it
I don't know.
back.
I have to. You're sure that's what you want to do? Then or you could bake, and I'll solve it for you guys. That's right.
I mean, you're gonna solve it on your United anyway, so I would be able to tell us for a second. Oh, I see what you mean. I overcomplicated it, huh? For sure. You only wanted to do it once. The back half. Well, the way you would have done it, it would be. What's that? No, I did it twice. That's why I overcomplicated it. So this is the back half right here. And then the back half. Then I do the back half again.
All right. Are you able to solve it?
Take a look at
I look at flow there, but I think it's just, it's really there.
See, every term in the bracket can be considered as a vector, either the curly bracket, the square bracket, or the parentheses. So we can apply good inside out or outside in. Dot product and from this one? No, that cannot be in the vector, right? That's the key. Dot product. But this? Yeah. All right, I'll solve it for you quickly. Now, give me your whatever you thought, give it to me. Huh? You can redo it later. No, no, you can find it for a minute or two. So I can read it. This will not be graded for correctness. This will just, you'll just get credit for it. Huh? Huh? I'll solve it. Just so this will not, you will not get credit for if you are correct, or not get any partial grade. You will get full grade. Okay. So what you do is, what is the expansion of this? It would be B A dotted with AC, right? Dotted with H minus right. So now you substitute back H, right? So what is H? A cross G minus A cross G If you look at, see, if you look at, you can just keep this as it is. Okay? All you need to do is B, E, A cross
Subheading B cross C or G.
G is B cross C. So all you have to do here is, again, back minus cap, right? And this does not change because this is a scalar. You can move around, right? Okay. The thing is, it doesn't, it's not over yet. Okay. If you're giving up here, then it's not wrong, but you've not completed the process. You want to simplify this further, right? So how do you simplify this further? Huh? We have A dot C into dot D, right? See, A dot C is what? It's a scalar. You can move it out. And you do a distributive property. We discussed a distributive property, right? So you have A dot C into E dot B minus A dot B into dot C. And what happens here? This is just a scalar. So nothing changes here. You can just use this as a scalar. But what you need to extract out is, you have A dot C, A dot C, A dot B and A dot B. Okay? You have to be able to extract that out and show you fact, this is common. Do you see any anything which does not fit in there? So what is this? You have to tell me which, whether, if you look at this, what is the end product? Is it a scalar or a vector? Huh? It has to be a vector. You should not even question it. It's all crossed. Unless there is a dot, it cannot become a scalar. It's all crossed. So if you look at here, what is this? Scalar minus scalar times a vector. That's a vector. Scalar times a vector. That's a vector. Right? And then scalar times a vector. That's again a vector. You end up with a vector. Yeah, I need room. I cannot use this thing. Can you just write on your own?
It's still